Okay, let's take a look at question number 10. Question 10 says, the average heights of teenage girls are normally distributed with a mean of 157 and a standard deviation of 7. So what that means is that we have x normally distributed with a mean of 157 and a standard deviation of 7. So the first part of this is pretty straightforward. It says, what's the probability that a teenage girl's height is greater than 170? So we want to calculate the probability that x is greater than 170 centimeters, which is basically the same thing as saying the probability that z is greater than, and we're going to do the little z calculation right in here, 170 minus the mean, 157, divided by the standard deviation of 7. Now, if you plug that in, you're going to get the probability that z is greater than 1.86. Now, of course, your normal distribution table doesn't do greater than, it's all less than. So what we have to do is switch this around to the probability that, 1 minus the probability. 1 minus the probability that z is less than 1.86. So let's go look up 1.86 in the t-chart. There's my z-score. Whoops. Here's my z-score table. And we want to look up 1.86. So we're going to go over here. We need 1.8, which takes us to here, and then we need 6. So 1.8 and across to 6 is 0.98 or 0.9686. So 1 minus 0.9686, which gives us a final answer of 0.0314 or 3.1%. Now the next part isn't quite as straightforward because it says what range of heights would occur about 90% of the time. So let's remember that our normal distribution looks like this, and we want the middle 90% is what that's asking for us. We want the range though. So I have to figure out what this lower bound is here and what this upper bound is here to give us this 90% in the middle. Well, if it's 90% in the middle, I know that it's 5% out here, and that this is 5% out here as well, which means that this is going to, we want everything less than this and less than this. So less than this is 5%. So what I want is the probability that z is less than the lower bound. We know that that is 5%, 0.05. And then the probability that z is less than the upper bound, well, everything less than this point here, there's 5% over here, so that means there's 95% over here. So we want that to be 0.95. So what we have to do is reverse what we're looking for in the z-score to figure out what our lower and upper z-scores are. So our lower bound has to be, let's go and take a look. So our z for this, let's pull up that table again. We're looking up 5%. So what you have to do is look in the body of the table for 5%. So it's 0.05 is what we're looking for. So 0.0, there, right here. This is the closest thing we see to 0.05. So that's negative 1.64. And while we're here, let's look up what 95 is. So if we go over here for 95, that's right about here. So that's 1.65. So we know that for the lower bound, we need to use a z of negative 1.64, And for the upper bound, we need to use a Z of 1.65 or 64. It's not going to make a whole lot of difference here. But negative 1.64 has to equal the lower bound minus 157. We're doing the Z calculation here because we know that the Z has to equal this, divided by the standard deviation, which is 7. And then over here, we're going to get 1.65 equals the upper bound minus 157 divided by 7. So now we just have to solve these. This is going to give me negative 11.48, which equals the lower bound minus 157. So what I did was multiply by 7 on both sides. So this is just 7 times 1.64, and then add 157 on both sides. So this gives us about 145.5 equals the lower bound. And we'll do the same thing over here. 7 times 1.65 is 11.6 or 11.55 equals the upper minus 157, and then add 157 on both sides, which gives us basically 168.6, which will equal the upper bound. So here's the range of the data from here to here. So 145.5 to 168.8 will give us the range of data, or range of 90%. It's really, I'm going to have to erase that. Range of 90% of data. Okay, hope that helps.